Hey guys! Today we will go over some electrical circuit basics and get equipped with some circuit solving abilities. To start us off, it is important that we learn the equations listed. Kirchhoff's current law states that the current going into a junction on a circuit must equal the current leaving that junction. Kirchhoff's voltage law states that the voltage around a closed loop is zero. Ohm's law gives an equation that relates voltage to current. And the law of conservation of energy says that the power supplied to a circuit must equal the power being consumed by the circuit at any given time. We will go into more detail in the next slides to give a more practical understanding of these laws. Kirchhoff's current law is illustrated in the figure in the relationship here. The current I1 is flowing into the junction X. In order to satisfy Kirchhoff's current law, I2, I3, and I4 must add together to equal I1. Kirchhoff's voltage law states that the sum of the voltage around a closed loop is equal to zero. The sign convention across each circuit component tells us if the component adds voltage or it subtracts voltage from the loop. Say V1 is 30 volts, and V2, V3, and V4 are 10 volts apiece. We would start around the circuit at V1, 30 volts, subtract V2, leaving us with 20 volts, subtract V3, leaving us with 10 volts, and finally subtract V4, leaving us with 0 volts when we come back to V1. Ohm's law gives us a relationship between electrical resistance, current, and voltage. As an example, we can determine the voltage potential V2 by using Ohm's law. Given a current I2 of 1.5 amps, a resistance of 2 ohms, we determine that the voltage V2 is 3 volts. It is important to note that the current I2 is constant across the junctions shown. A circuit must obey the laws of physics. Energy must be conserved. An electric equation for energy is voltage multiplied by current. Engineers typically use this relationship to check that they have calculated voltages and currents correctly. Here we will conclude by putting all of our equations together and solve our very own circuit. This specific circuit is known as a resistor divider. We know that the current is the same throughout the circuit because of Kirchhoff's current law. We find the current using Ohm's law. I1 is equal to V1 divided by R1 plus R2. We find that I1 is 5 amps. We now want to find V3. We know from Kirchhoff's voltage law that the sum of the voltages around the current loop is equal to 0. This gives us the first equation, V3 is equal to V1 minus V2. We also know from Ohm's law that V2 is I1 times R1. We now have enough information to solve for V3. V3 is equal to 10 volts. We now check that our calculations are correct by using the law of conservation of energy. Power equals voltage times current. The voltage source V1 supplies power P1 to the circuit. The resistors R1 and R2 dissipate this energy in the form of heat. Thanks for tuning in to this circuit analysis tutorial.